So wanted to welcome everybody to today's webinar. My name is Ashley DiTomaso. I'm the local Broan area rep. But today I just wanted to give everybody a reminder that your cameras are going to be turned off to keep things running smoothly. I'm going to ask that you please post any questions in the chat so that we can answer them throughout. Also, as a reminder, this training is going to be recorded and posted online for future viewing. So feel free to take notes along the way, but you'll have that as a point of reference. And I'm going to be turning things over to Pat Nielsen from Broan. He's going to be our host today. He's going to run through our codes and basic ventilation products and efficiencies. And so with that, I welcome Pat to the floor.
All right. Thanks, Ashley. Yes, welcome everyone. Again, my name's Pat Nielsen. I've been with Broan for 21 years now, and most recently I kind of focus on codes and standards and HVI and things like that. So hopefully this training will be helpful for you. So we'll get started. So why are we concerned about ventilation in homes? We're building them tighter than ever, right? We have better doors and windows. Builders want to meet energy codes. Now they want to get their 45L tax credits. The kind of mantra in the ventilation industry is build tight, ventilate right. We have to worry about indoor air quality, but don't let that stop you from building a really tight house. We have the products today to ventilate them, and we can have both an efficient, easy to heat and cool home and one with good indoor air quality. And the pandemic, it's something that's really impacted the ventilation industry. People are more concerned than ever about the air that their families breathe. So, when the pandemic was at the high point, the CDC and ASHRAE both put out kind of public service announcements saying, hey, folks, it's all about ventilation. You got to get the bad air out. So, again, it's raised awareness. We can see it in the growth in sales of IAQ monitors. You can go online and find a bunch of different monitors for a couple $100, and the sales of those are taking off, which tells you people are really concerned about the air they're breathing. And we're seeing a lot of builders changing their messaging, from we'll build you a beautiful home to we'll build you a healthy home. It's really a swing in the industry. And 1 out of every 5 people have respiratory problems, even pre-pandemic. So just a basic reason to be concerned. So what pollutants are we concerned about that we want to ventilate out? One is excess moisture. And when it comes to, electrical folks like yourselves, you're very focused on bath fans, and we really want to get that shower moisture out. So if you look at this graph on the right here, it kind of shows, bacteria and viruses and so on, where they thrive. The healthy zone for relative humidity in a home is between 30 and 60 relative humidity. You can see once you get above 60, all these bacteria and viruses really thrive. They reproduce and multiply, and that's not the good things we want to have in our house. So that's besides mold and mildew on our tile and grout, that's the health reason you don't want excess moisture. We're also concerned about particulates, especially PM 2.5. I don't know if you've heard of that. It stands for particulate matter, 2.5 microns and smaller. There's also PM1, PM10, but 2.5 gets a lot of focus because that's the size of particle that can goes right through our nose, right through our lungs, and into our bloodstream. Very unhealthy to be breathing PM 2.5. Gases and VOCs, formaldehyde that comes off carpet. People love the smell of new homes, but unfortunately it's, they're smelling a lot of things that they shouldn't be breathing. VOCs off paints and, cabinetry and so on. So carbon dioxide, that's a good kind of canary in the coal mine, if you will. It's a good proxy for your indoor air quality. If you have a very tight home and you're not getting stale air out and fresh air in, if your CO2 levels get, 1,000 ppm or greater, people start feeling lethargic and not a lot of energy and so on. So something another reason we want to get fresh air in. And then obviously odors from different rooms in the home. So why is it more challenging? One, we're making homes tighter again. Spray foam insulation not only gives you that thermal value, but also that air sealing value. I don't know if you've heard of a product called Aero Barrier. It's a way at right before you finally seal up a home, you can really get all the last little nooks and crannies and pretty much get a home as tight as you want. I don't know if you've heard of a building tightness test. It's also called a blower door score. It tells you how tight a home is. Back in the 70s, the average blower door score was 12 ACH 50. Stands for air changes per hour at 50 pascals of pressure difference. So you get a home depressurized to 50 pascals to the outside, and then you look at how quickly air wants to rush in through all the building envelope holes. Today, with the newer energy codes, we're at low single digits at typical homes on blower door scores. That shows you how much we've tightened up homes. And again, great for saving the planet and heating and cooling bills, but have to make sure people aren't living in a Ziploc bag and breathing bad air. So when we tighten an envelope, we lower the sensible loads. Sensible is, think temperature when you hear sensible, make easier heat and cool, but we increase the latent loads. Again, all the humidity we produce by showering, by cooking, boiling pasta when we cook, just breathing, we breathe out humidity. That all, has no place to go in a really tight home if you don't have good ventilation. And you may have experienced in shoulder seasons like spring and fall, when it's not cold enough for your furnace to run and not hot enough for your AC to run. Um, your AC does two things: it cools and it dehumidifies. So if the AC isn't running to cool, it's also not dehumidifying. So you can really get those cool, clammy conditions. So I'll run over a few ventilation basics. So if you guys are not familiar with HVI, I suggest, it's something you want to check out. There's a great website they have, hvi.org. You might want to check it out. So that's where you can see the certified products directory. You can see what any product's certified airflow is, CFM, it's zones, it's watts. And, on the bottom here, you kind of see an example if you look at their certified products directory. So you really want to look for that HVI certified product seal. All Broan NuTone products we make are HVI certified, but, you kind of have to be on the lookout for some that are not. So HVI, they not only certify the original product, but then they randomly go in and check test by products on the market and make sure that manufacturers are keeping the performance levels that they said they would. So on the right, I want to talk a little bit about zones if you're not familiar with them. Some people ask, why do you use zones instead of decibels? Isn't decibels the kind of more common measure of sound? Decibels are kind of confusing because they are on a logarithmic scale. So like 66 decibels is twice as loud as 60 decibels. A lot of people can't wrap their head around that. Zones are linear scale. So 2 zones is twice as loud as 1 zone. They focus on the human audible bandwidths. They're measured in tenths of a zone up to 1.5, and above that, they're measured in half zone increments. So you'll never see a fan certified at 1.7 zones, for instance. Very noteworthy, less than 0.3 is the quietest achievable rating you can get. For instance, you see one of our Broan premium fans rated at less than 0.3 zones. You bought the quietest fan you can get. They determined the 0.1 and 0.2. The human ear can't hear that anyway, so it doesn't make sense to rate there. And then in terms of what's the zone sound like, 1 zone is compared to a quiet refrigerator running. If you're home alone and your refrigerator kicks on, you can hear it, but it's not objectionable. Whereas 4 zones, that's, your typical economy fan that most people do consider objectionable. So static pressure is a big deal. I don't know how many of you folks get involved with the actual ducting of the fans, but all bath fans you'll see have what's called a fan curve like this. Very important. So this is what a typical fan curve would look like for an 80 CFM fan. So you can see on the vertical axis here, we have static pressure. Static pressure is a measure of resistance to airflow. You want that bath fan to be able to push the air out as easily as possible. You want the duct run to be nice and short and straight. If it's, a lot of bends and elbows and is very long, it's harder for the air to get out. And then on the horizontal axis, you have the flow. So if you look at 0.1 inches of static pressure, let's follow this blue line across to the fan curve. You'll drop it down, you'll see it moves 80. That's where like a typical Broan AE80 bath fan, this is what the fan curve might look like. But you'll notice the industry is starting to say a 1/10 inch is unreasonably low. Most installations have more static pressure than that. Unfortunately, high static pressure is a bad thing. So the industry is more looking at 1/4 inch static pressure. So if you look at a 1/4 inch, this fan moves now only 60 CFM. So, if you're trying to meet a code and so on, really look at what static pressure you're being measured against and find out how that fan performs at that static pressure. Again, don't neck down the diameter. If it's a 6-inch duct connector fan, keep the ducting 6-inch. If it's 4, keep it 4. Don't neck it down to 3. So in the code, in the IRC code, if your state is on, and I think Pennsylvania is on 2015 or 2018, these are the options for the inspector HERS rater to verify the fan airflow. The most common way is with this allowable duct length calculator. And as you can see, this whole duct length table, duct length table, this is all predicated on the fan's 1/4 inch performance. So if you're looking at an AE80 fan, you're not looking at 80 CFM, you're looking at 60 CFM. So unfortunately, we want people to duct with rigid duct, but most still duct with flex. So per the code in a bathroom, you have to move at least 50 CFM when it's all done and installed, not the rating on the fan. When it's all done installed, it has to move 50. So the IRC is saying 3-inch ducting is not allowable. When you see an X in this chart, it's saying it's not allowable. A fan that's only rated, when you're trying to move 50 at a 1/4 inch, 3-inch duct is never going to get you there. So you need a minimum of 4-inch ducting. And you'll see then you're allowed 56 feet of duct. But the caveat, that sounds like a lot, but the caveat here, back up to this first bullet, is you have to subtract 15 feet for every elbow. So let's say the duct system has 3 bends or elbows. 3 times 15 is 45. Take 45 off 56. Now you're only allowed 11 feet of duct. Inspector is going to be looking to, check out the duct installation and make sure you're meeting that. The other way you can apply, that the inspector can actually do a flow hood test, like you see in this image on the right. Actually put a flow hood up against the fan grill and check the actual airflow. And then the third way is with manufacturer's design criteria. They're saying the manufacturers know their product, so if they say a given model with a given ducting is going to work, you can use that too. So this is a tool we have on our website, at our Broan NuTone website. So you can go in there and pick the fan model, put in your design flow rate. In most cases, this is going to be 50 CFM because the code says you have to move a minimum of 50 CFM. A few simple drop-down menus here. You say I'm using 4-inch flex and I have 2 elbows, and it'll return an answer of 41 feet. It's saying if you use this product to move 50 CFM, if you keep your duct run under 41 feet, you'll get at least 50 CFM. So kind of a slick tool we have out there. So I want to get into ASHRAE now. So ASHRAE, a key thing with this is ASHRAE 62.2 is a standard, not a code. So, this is a standard that gets adopted into the different codes. So it's revised every 3 years, as you can see. They'll do addendums in between. A few states use the more modern versions, but the IRC, again, what Pennsylvania uses, they use the 2010 version because it's a lot simpler. So what does 62.2 call for? For, as I mentioned earlier, for local or spot ventilation, kind of the traditional way people think of ventilation, in a bathroom, you have to have 50 CFM when it's all said and done installed. So again, your common traditional 50 CFM fan, like a Broan 688 with 3-inch ducting, is no longer acceptable. You have to step up to something with 4-inch ducting, and it moves at least 50 CFM at a 1/4 inch. And then in the kitchen, if you're involved in range hoods, it has to be moving at least 100 CFM when it's all ducted. Now, the newer piece of 62.2, of course, is dwelling unit ventilation. This is the idea of whole house 24-hour ventilation. This bath fan's great for getting, shower humidity out and odors, but 24 hours a day, we want to turn around the air in the home, get bad air out and fresh air in. So here's where we'll talk about the ASHRAE 62.2 2010 version. Before I do that, kind of going back to sound, for local exhaust, it says the fan should be maximum of 3 zones, but this is in the ASHRAE 62.2 standard. The IRC code doesn't carry these over. So technically, to meet code, you don't have to have your exhaust be 3 zones or your 24-hour fan be less than 1 zone, but it's always a good idea. You know, you don't want callbacks from the builders, people complaining the fans are too loud. The idea here is if fans are too loud, people are going to turn them off, and then they're getting no ventilation at all. I mentioned the importance of HVI. So the 2018, and yes, here I did confirm, Pennsylvania uses 2018 IRC. It says exhaust equipment must be listed and labeled as to meeting these standards, and that's what HVI does for you. So if the inspector doesn't see an HVI certified label on a bath fan or range hood in the new construction, they can say, it's got to go, I need a certified product. These are some efficacy requirements, so just be aware. Pennsylvania is also on the 2018 Energy Code, and what that means is, like for bath fans, if it's a bath fan up to 80 CFM, you have to be at least 1.4 CFM per watt. If it's 90 or greater, it has to be 2.8 CFM per watt. If you are using Energy Star fans, you can be rest assured you're good to go. Energy Star fans meet these minimums. So talking about dwelling unit ventilation again, here are the requirements for that 24-hour ventilation. It's pretty simple. It's 1% of the square foot to determine how much airflow you need. It's 1% of the square foot plus 7.5 per person. And to estimate how many people are in a house, they use number of bedrooms plus 1, figuring, you know, guest bedrooms have 1 person, 1 kid, but the master bedroom probably has 2. So a 3-bedroom home probably has 4 people. So in an example, 2,500 square foot, 3-bedroom home, 1% of 2,500 is 25 CFM for that part of the equation. And then 7.5 times 4 is 30. Add those together and your typical home needs about 55 CFM. You can also use this chart on the right to arrive at the same number. The table has to round up to the worst case scenario. So here you'd get 60 in that example. So how do we achieve fresh air? So this is that dwelling unit 24-hour ventilation. There's 3 ways of going about it. The industry is kind of going towards balance, you know, H&E RVs, but there's still the most common method is running an exhaust fan 24 hours a day. You know, take a good, quiet, energy efficient fan, you know, with a DC ECM motor and run it 24 hours a day. So the idea here is you're going to pull stale air out at that, say, 60 CFM, and through the nook, you'll depressurize the home a little bit, and through the nooks and crannies left in the building envelope, 60 CFM of fresh air will make its way in. So you'll kind of get that air change. So again, how does it work? We're going to pull stale air out, replace it with fresh air making its way in because the home is depressurized. Builders love this exhaust strategy because it's low first cost. You know, just you can kind of kill 2 birds with 1 stone. You want a good bath fan in the, say, master bathroom anyway, just have it controlled to run 24 hours a day. And it's low maintenance. With some of the other options like H&E RVs, you need filters. There's no filters to replace with a bath fan. And of course, there are models available like our ZB series where you can kind of, again, kill 2 birds with 1 stone, like our ZB 110. You can set inside this dial inside the housing for 55 or 60 CFM what you need continuous. But then when a person comes in the shower, they flip the switch and it goes up to the full 110. They turn the switch off and it falls back to this 55. So you're getting the max airflow when you need it showering, but you're also just barely meeting the code requirement for the whole house dwelling unit ventilation. And then, of course, we have humidity sensing versions of this. It'll automatically sense a rise in humidity, kick it up from this lower continuous rate to full 110. When it senses humidity's gone, it'll drop back down to the continuous rate. So that concludes my portion of the presentation. Now Ashley has about a half dozen slides, kind of talking about some of our Broan products that you can use to meet these code requirements. So go ahead, Ashley.
Thank you, Pat. So we have a pretty wide spectrum of products and price points. So this particular slide, I think, does a really nice job of visualizing what that looks like. So everywhere from basic to premium with intermediate options in between. Looking at each of the categories, you can kind of get a feel for where they're going to fall in any given price point. So we'll deep dive into many of these. So we'll start first with the Flex in the Room side. Are
Oh,
you able
sorry.
to?
I
No,
need
you're
to
fine.
advance, don't I?
Thanks, Pat.
There you go.
So the Flex DC series is quite simply our most flexible and most efficient fan that we offer. Some of the key characteristics of this particular fan is that the housing on it is going to be 50% tighter compared to a standard exhaust fan, and it's going to have a smart DC motor. So these two characteristics are going to make it 2 times more efficient than much of the competition. And that is really the key characteristics of this entire series. In addition to that, though, it's going to be a whisper quiet sound to it. You have adjustable CFM 50, 80, 110, and all of that is going to be below 1 zone. So at its quietest, it'll be 0.3 zones. And depending on the CFMs, you're still going to have a very nice, quiet, efficient fan. It's also really, really easy installation on it, easy flange and easy duct connector on this unit. Then moving into the low profile series. What's great about this is exactly what it says. It's low profile. So the unit is going to be under 4 inches. It's designed to fit in a 2x6 wall. And it's also designed to be really, really efficient. It's got a brushless DC motor. So we know that that is going to give it peak performance, energy, efficiency. And we've got this true CFM technology in these fans. What that's going to do is it's going to allow the fan to maintain its CFM even under high pressure static installations. Also a very quiet fan. You're at 1.2 zones at 100 CFM or 0.4 zones at the 50 CFM. And it's entirely adjustable from 50, 80 to 100. It also has the continuous run built in, so it'll meet code in many circumstances. Then we move on to the Ultra Green series. So what's great about this is that it has humidity sensing technology that'll automatically turn it on and rise to the humidity levels. It also has motion sensing technology, which will automatically turn the fan on when motion is detected. It's got very energy efficient lighting with the ultralucent lighting technology. Really easy install with these retractable telescoping mounting frames. So they'll allow for the fastest and most flexible installation. It's pretty universal. Corrosion resistant housing. And again, word of the day, really quiet operating performance. So these units, even at 110 CFM, are at 0.3 zones or less. So really, really quiet and efficient and powerful with this unit. And then the last series that we're going to touch upon today is the QTDC series. So high power, high efficiency, low sound. Those are the 3 best things I think that you can use to describe a fan. It's whisper quiet at 110 CFMs. It's going to be 0.3 zones or less. And at 150 CFM, you're at 0.7 zones. So well under the 1 zone, which is phenomenal. The power on this is going to be adjustable and selectable between 110, 130, or 150 CFM. So great performance on this unit. Also, another really tight housing on this. It's 30% tighter compared to the competitive models on this unit. So you're getting an Energy Star qualified unit, brushless DC motor, and then also dimmable LEDs with this one. So high power, high efficiency, low sound, everything you need in a premium quality fan. So that about wraps up the Broan product portion. Feel free, if you guys have questions, to send them into the chat, and we're happy to address those. But also, this is going to be shared with everybody afterwards, so feel free to reach out to your Schaedler Yesco sales rep if you have any particular questions. But otherwise, I thank you all for attending today. And if you'd like more information, as I said, please direct the additional questions to your sales rep, or you can email Schaedler Yesco directly at info@sydist.com. But I appreciate you all joining today, and I hope that you have a great rest of your week.